In this section, we're given polynomials by their properties and we want to find the equation of the polynomial. Let us look at example 1. We're given a third order polynomial and we know that the point a11 is an inflection point of it, and we know that it passes through the origin and there it has gradient m equals -1. Since we're talking about an inflection point and about gradients, we know we need the first and the second derivative, but let's start first with the third order polynomial. What is the general equation of a third order polynomial? It is this here: f of x is a times x to the power of 3 plus b times x squared plus cx plus d. Now we need the first and second derivative, try to find them, and here comes the solution. So, and now that we found the first and the second derivative, also we try now to use these pieces of information that we're given to set up an equation system. Let us start with the information that is most simple to use, namely that the origin lies on the graph. So the point 0, 0 is element of f, which means when we insert it, we get, it means f of 0 is 0, we insert it, and we get that d is equal to 0. As a second one, let us use that the gradient at the origin is -1 here. What does this mean? Well, that means that f dash of 0 is 1. We can insert that into the equation here, and what we get is this here, and in the end we find c is equal to -1. Next step, the next information that we're going to use is that the point a11 lies on the graph. So a11 is element of f, we can insert it into the equation and we get this equation here. Now we know also that c is -1, so we get a plus b minus 1 equals 1, so adding 1 we get a plus b equals 2. And the last piece of information that we have is that this is an inflection point, so this means that the second derivative at x equals 1 is 0. So we can insert now the 1 into this equation and set it equal to 0. Well, this simplifies to 3a plus b equals 0 by dividing by 2, and we can set b equal to -3a by subtracting 3a. Now we can insert this in here, and we get a minus 3a equals 2, which yields in the end that a is -1 here. And now we use that a equals -1 to find b by inserting -1 here, so b is 3, and we can now write the function equation of this polynomial y equals, the a is -1, so I get -x to the power of 3 plus b is 3, so plus 3x squared, and the c is -1, so I have here -x, and d we said is 0, so it disappears. In example 2, we're given a fifth order polynomial, and we know that it is symmetrical with respect to the origin. Additionally, we know that it passes through this point P here, and that it touches the x-axis at x equals -2. So let's start by writing the general equation of a fifth order polynomial. Order here means the degree is 5, and let us simplify it from the beginning. We know it is symmetrical with respect to the origin, so we know there can be no terms with even exponents. So what must the general approach be? It is f of x is a times x to the power of 5 plus bx to the power of 3 plus cx. Then continue, we need when we look at it here, since we know it touches the x-axis, so we'll need the first derivative. So find the first derivative. Here it comes. So that's the explanation, and here it comes, the first derivative. And now let's find the equations. Try it on your own for a moment. There are three unknown, the a, b, and the c, so we need to find three equations. Here they come. The first one is that the point P lies on the graph, so f of 1 is 3. We get this equation. Then the second one is about this point here. We know that the graph touches the x-axis at x equals -2, so we are given one point, namely the point -2, 0 lies on the graph. So we have f of -2 equals 0, and we get this equation here. And then additionally we know this point does not only lie on the graph, but the graph touches the x-axis, which means the derivative is 0. The tangent is horizontal, so f dash of -2 is equal to 0, and we find this equation. Now we have an equation system, and we can simplify the second equation a little bit. So our equation system becomes this here, and now taking the second minus the first equation and the third minus the second equation, we get this equation system here. And here we can simplify that by dividing by 3, and we can solve this equation system, or here divide also by 8 and solve it for b, and we get this second equation. And now we can insert this here in here, and we get that -3a equals -1, so a equals 1/3. Now we can insert that one into the 2 star, which yields that b is -8/3. And now we take these two results here and we insert them in here. And we find this equation, so c is 16 divided by 3. So we found a, b, and c, and we can insert them in here. And we find our final equation for our polynomial function is this here.